Hey guys, there are several ways to factor a trinomial, and I am happy for you to use any method that works. But for the purpose of this video, I'm going to stick with sort of one method that's easy and it's the easiest algorithm to teach. But I'll confess this isn't even the method that I use when I factor a trinomial on my own. But in the videos kind of going forward, this is gonna be the method that I'm gonna try and sort of reference. Okay, this method is gonna rely heavily on non-complete square, on factoring by grouping. So if you've skipped over the factoring by grouping video, you do want to make sure that you give it a good look, because I'm going to sort of breeze through that part, assuming that you've already watched the video. So all that being said, the hardest part for students in the beginning for this method is just some sign rules things. Okay, so I want to review just some basic facts when it comes to positive and negative numbers, specifically because we're going to be looking for a magic pair of factors that do a certain thing. And it's going to be easiest to think of it forwards first before we get to the part where we're going to have to do it backwards. Okay? So this is what I want to remind you guys of. Let's just pick a pair of numbers. If I were to pick, say, positive 3 times positive 6, I would get positive 18. And I know you're pulling your calculators out to check me, but I think we'll all agree that a positive times a positive is always going to be a positive, right? But notice what happens. I mean, this is not going to be amazing. I mean, you don't have to sit down for this. If I were to take those same numbers 3 and 6 and I add them together, 3 plus 6 is going to be positive 9, okay? If I were to take a different pair of numbers, say negative 4 times negative 10, a negative 4 times a negative 10 is actually going to be a positive 40 as well, because a negative times a negative is a positive. But if I take those numbers negative 4 and negative 10 and I add them together, I'm going to get an even more negative number, negative 14. Okay? So what's kind of worth pausing here and realizing is when I multiplied these two numbers together, in both of these cases, I got a positive. But when I added those two numbers together, in one case I got a positive, in one case I got a negative. And the difference was, were both numbers positive or were both numbers negative? Okay, so it's going to be a key bit of information in a little bit. Let's do another pair of numbers. This time, let's multiply 12 times negative 5. If I take positive 12 times a negative 5, positive times negative is negative, and otherwise 12 times 5 is 60. And if I add those two numbers together, 12 plus a negative 5, or really 12 minus 5, is a positive 7. Okay? But if I took a 4 times a negative 8, 4 times negative 8 is negative 32. And the sum of those two numbers, 4 plus a negative 8, is 4 minus 8 is negative 4. Okay, so what's worth noting this time is, in these two examples, the product in both cases was negative, because I took one positive times one negative, one positive times one negative, but their sums, in one case one was positive and one was negative. And the difference was the sign of the larger number wins. Here, my positive number was bigger than my negative number, so to speak, and so the sum was positive. But here, the bigger number, so to speak, was the negative number, and so the sum of these two numbers was also negative. Okay? So just kind of put a pin in that, and let's practice an example where we factor a trinomial, and we're going to turn it into a 4-term polynomial so that we can do factoring by grouping. Okay, so for this method of factoring, I'm going to talk you through the steps, but I'm not going to write the steps down because the words, honestly, just written out, make it look way more confusing. Not that this is a super duper simple method, but I don't want to scare you guys off with sort of the written steps, okay? So the method that we're about to use is called either the AC method or the split B method, or others. There's probably a dozen names for it. So what we're going to do is we're going to first kind of label what are A, B, and C in this trinomial. And A, B, and C are the coefficients of each of the terms. So if I have AX squareds, and then BX's, and then C is for my constant, then here I would say that A equals 2, B equals 15, and C equals 18. Okay, full disclosure, I had to pause the video here and go do something for about an hour and a half, and I don't want to start all over, so I'm just going to repeat myself for a moment and offer you a half-hearted apology. Okay, so quick recap of what I just said. We're going to call this the AC method. A is the coefficient of the x squared term, B is the coefficient of the x term, C is the constant term. So if I've got the trinomial 2x squared plus 15x plus 18, A is 2, B is 15, and C is that 18. So the way we're going to do this is we are going to try and find a magic pair of numbers that are going to add up to 15 that are going to equal the same product as 2 times 18, okay? But the key thing is two numbers that add up to 15 because we're going to split this term up into two separate terms to turn these 3 terms into 4 terms, okay? So we start by multiplying A times C. So for this problem, A times C is the same as 2 times 18, which is 36. So we're going to find all the factors of 36, and we want to find the magic pair that hopefully exists that adds up to the value of B, 15, okay? So if you just go like in any like random order, it's going to be really easy to overlook maybe a less considered factor, okay? So I like to go kind of in order, and I start with 1. Everything is divisible by 1. And then I just kind of work my way down the number line. So 1 times 36 is 36. Of course, 2 times 18. 3 times 12 is 36. 4 times 9 is 36. 5 doesn't go into 36, so I'm going to skip it. 6 goes into 36 6 times. And then I've got permission to sort of stop. I know 7 isn't going to work, not only because it doesn't work, but because the next number here would be 7, and that's larger than what I have right here, okay? So if this had been, say, for example, 6 times 10, then I could hypothetically try 7, 8, 9, but as soon as I get to something as large as this one right here, then I know I'm done. Nothing bigger than this number 6 is going to work, okay? So we've got all of our pairs of factors of 36. So now the next thing is we need to consider our signs. This is why we talked about this up here. Why are some products positive and why are some products negative? Okay, well, if the product 36 is positive, positive numbers come from either 2 positives or 2 negatives. Well, since the sum is also positive, then that means I want my 2 numbers to also be positive. So I started with the easy case where everything is positive, okay? So now I'm gonna add these 2 numbers together, these 2 numbers together, these 2 numbers together, and so on until I find the pair that add up to 15. Okay, so 1 plus 36 is 37. 2 plus 18 is 20. 3 plus 12 is 15. 4 plus 9 is 13. And 6 plus 6 is 12. And again, we were looking for the pair that adds up to 15. So it's this right here. So since 3 plus 12 is 15, then I can take these 15x's and I can split them into either 3x's plus 12x's or 12x's plus 3x's. It's not going to matter. You can do it either way you want. Okay? So just because, I'm going to do it the way I wrote them as a positive 3x plus 12x. Okay? Sorry, I just had a brain fart. I hope you couldn't smell that. So this right here is equivalent to these 15x's right here. Agreed? 3x's plus 12x's is 15x's. So then what I'm going to do is I'm going to bring it down with the 2x squared and the 18. All right. So now I started with 3 terms right here, and I've rewritten these 3 terms as an equivalent expression with 4 terms instead. And now that it's 4 terms, I'm going to do the factoring by grouping. I'm going to pair those guys up, look for little GCFs, and go from there. So first pair, second pair. From the first pair, 2 and 3 don't have any factors in common, but the x squared and the x do have x's in common. So I can pull out an x from those 2 terms, and it's going to leave behind the 2 and the other x there, plus a 3 right there. From the second pair, my third term is positive, so I want to pull out a plus. And then otherwise, 12x and 18 are both divisible by 6. They have 6 in common. And so if I divide both of those by 6, 12 divided by 6 is 2x. 12x divided by 6 is 2x, plus 18 divided by 6 is 3. I do a visual check. Did I end up with the same exact things in parentheses here and here? I did. So that means 2x plus 3 is a GCF. And when I pull that out front, that leaves behind the x plus the 6. Shebang. And that's my factored polynomial. Okay, if I were to re-multiply stuff together, let's do that over here on the right side. I can sort of do a check, and we won't do this very often. But if I take 2x plus 3 and multiply it times x plus 6, let's make sure that I get the original polynomial back. So 2x times x is 2x squared. 2x times 6 is 12x's. 3 times x is plus 3x. And 3 times 6 is 18. The 2 middle terms are like terms, so we combine them together. 2x squared plus 15x plus 18. Voila. And you'll notice there's that magic pair. The 12x and the 3x, the same 3 and 12 we had right there. Okay? So we got the same thing here that we started out with. So this in black here is our correct factored polynomial. Okay, let's do just a few more examples for practice sake. And let's introduce some negative signs in here. Okay? Okay, so let's take a shot at factoring 9x squared plus 3x minus 2. Okay, we're going to use this AC method again. So let's once again label what are the values of A, B, and C. So A is 9, B is 3, and C equals negative 2. So we're going to multiply A times C, which is 9 times negative 2. 9 times negative 2 is negative 18. And we want to find the factors of negative 18 that are going to add up, to give us B, which is 3. Okay, so again, I'm going to focus on the 18, list all my possible factors first, and then I'll worry about my signs. So I can think of 18 as 1 times 18, 2 times 9, 3 times 6, 4 doesn't go into 18, 5 doesn't go into 18, and then I'm to 6, which I got right there. So that's as big as they get on the left side. So that's all my possible pairs of factors. So then I go, my product is negative. And in order to have a negative product, that means I need to have one positive and one negative. But the sum of those numbers has to be positive. So in order for the sum to be positive, then that means my bigger number has to be positive and my smaller number is negative. So I'm going to go down the line here for my smaller numbers. I'm going to make each of them negative. Shaboom. And now I'm going to add up. Negative 1 plus 18 is 17. Negative 2 plus 9 is positive 7. And negative 3 plus 6 is positive 3. And that's the pair I'm looking for. The ones that added up to positive 3. So that means I can take my 3x here. I can split them up as minus 3x plus 6x. I'm going to bring down my first term, the 9x squared, and my second term, the minus 2. And then we're going to pair up and do factoring by grouping again. So amongst the first pair, both 9x squared and a minus 3x are divisible by 3x. So if I divide out a 3x from the 9x squared, I have another 3 and another x minus 3x divided by 3x is 1. Okay, my third term is positive, so I'm going to pull down a plus. And then I have 6x minus 2, and both those terms are divisible by a positive 2. So if I divide 6x by 2, I get positive 3x. Negative 2 divided by positive 2 is negative 1. I check my parentheses, 3x minus 1 matches 3x minus 1, matchy matchy. So 3x minus 1 is a GCF that I can pull out front, open up a new set of parentheses, what's left behind? The other 3x plus 2. All right, so like we did before, we can check by multiplying, but for time's sake, we're not going to do it. You can pause the video and try it on your own, but you're going to get the 9x squared plus 3x minus 2. Okay, let's do maybe 2 more. Okay, let's try applying this method on x squared minus, oh, that's a typo. That shouldn't be a 12x, that should be a 2x. And every time I try to edit stuff out, weird stuff happens. So let me just get my little eraser. Shoop. Okay, x squared minus 2x minus 120. There's no way y'all find that as amusing as I do. Okay, so let's label our values of A, B, and C. And I'm labeling it here just for the sake of everyone watching along. If you don't find that you need to label the values of A, B, and C, there's no need to. You don't have to. This is just so me doing the best I can to keep us all on the same page. Okay? So if A is the coefficient of the x squared term, and I only have the one x squared here, then that's my unwritten coefficient 1. Okay? If there's no other coefficient written, then it's an understood 1. All right? My B value, including my sign, is a negative 2. And my C value is a negative 120. So once again, I'm going to multiply A times C to get the product that I'm looking for. So A times C is positive 1 times negative 120, negative 120. And this time we need to find the factors that are going to add up to give me the value of b, which is -2. So, starting with 1 times 120. 2 goes in there 60 times. 3 is going to go in there 40 times. 4 is going to go in there 30 times. 5 is going to go in there, let me do a little bit of math, 24 times. 6 is going to go in there 20 times. I'm out of space, so let me extend my table over here. 7 does not go into 120. But 8 does. It is going to be 8 times 15. 9 does not go into 120. 10 does. 10 times 12. And then 11 does not go into 120. And then we're to 12. So that's it. So that's all the factors of 120. So like on the example before, our product is negative, which means I have to have one positive and one negative. And this time, if my sum is negative, like it was here, then that means my bigger number this time has to be the negative one. So I'm going to go and apply a negative sign to the biggers of all of these numbers. So negative, 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 negative. It's like talking to your dad. All right. And let's add them up. Negative 119, negative 58, negative 37, negative 26, negative 19, negative 14, negative 7, negative 2. And we're looking for the pair that add up to be negative 2. And so we've got it right there. Okay, incidentally, what happens if you don't get any of those magic pairs? What if nothing adds up? Well, that means one of two things happen. Either you missed a combination, just kind of double check your work, make sure you didn't overlook any numbers, or if you're confident that you got every single possible pair there is, and nothing adds up to that number, then what you have is a trinomial or polynomial that can't be factored at all. And there are actually lots of polynomials that can't be factored at all, okay? We just don't show you those because they're really boring to teach. Like, factor it. No. Okay. So, that's dumb. All right, let's take the negative 12 and the positive 10, and let's split up these minus 2x's as positive 10x minus 12x. And let's bring down the 1x squared and the minus 120. And then let's pair up and pull out little GCFs. So the little GCF of the first pair is just an x. And if I pulled out one factor of x, that leaves the other factor of x plus the 10. My third term is minus, so I'm going to pull out a minus sign next. And then 12 and 120 are both divisible by 12. So if I divide both those terms by negative 12, negative 12x divided by negative 12 is positive x, and negative 120 divided by negative 12 is positive 10. Did I get a match? I did. X plus 10s match up. So x plus 10 is a GCF. And what's left behind is the other x minus that 12. Okay, one more. Let's factor x squared minus 9x plus 14. All right, once again, A equals 1, B equals -9, and C equals 14. So let's multiply A times C together. +1 times +14 is +14. And let's find the values, the factors of 14 that are going to add up. I did it again. That are going to add up to be my B value, -9. So what are the possible factors of 14? 1 times 14, 2 times 7, 3 doesn't work, 4 doesn't work, 5 doesn't work, 6 doesn't work, and then we're to 7. So that's it. That's the list. So now what about the signs? Well, if my product is positive, that means my two factors have to be the same sign, either both positive or both negative. But since the sum is negative, then that means I need both factors to be negative. So I'm going to go through and make everything negative. Negative, 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 like teenagers. Sorry, I've got a 14-year-old right now, and everything is negative. Let's add them up. -1 minus 14 is -15. -2 minus 7 is -9. We got it. That's the pair that we're looking for. So I'm going to take that and split it up into -2x's minus 7x. Bring down my 14, bring down my x squared. Pair them up. Forgot my equal sign. How embarrassing. From the first two terms, the only common factor I have is x. So to divide it out leaves x minus 2 behind. The third term is minus, so I'm going to bring down that minus. But then other words, both 7 and 14 are divisible by 7. So divide out a -7 from those two terms. -7x divided by -7 is positive x. But positive 14 divided by -7 is a -2. Do they match up? They do indeed. So x minus 2 is a GCF. Open up a new set of parentheses. What's left behind? The other x minus that 7. And voila. Okay, so that is some practice factoring trinomials. And I'm sure you're going to have much, much more practice in the problems that are coming for the rest of the semester. All right, peace.